This is my third video in my series on converting a regular automobile alternator into a stepper motor. In this segment, what we'll do is review the Visual Basic program that is actually controlling the alternator stepper motor. This is a very simple application that I wrote in Visual Basic. It's version 6.0. The reason that I chose to do all this with the PC in lieu of using a stepper motor controller chip is I wanted to have a little bit of additional control, just to sort of gadgeteer around with the pulse widths, being able to actually control them to a greater extent than I think I would be able to with a store-bought device. So I have the ability with this little application to change the pulse width. I can actually change it, can make it considerably shorter or longer than what the actual interval is. So I can actually set up a situation where that when one coil steps prior to that coil being de-energized, this next coil will go ahead and energize. I really just I'm trying to optimize torque and RPM, and so I'm really just experimenting at this point. You can see this little application right now is running. I can change the interval by moving this slider bar at the top, move it down. You can see the RPM change. This RPM is basically just computed based on the interval. It takes 16 steps to make one revolution. So essentially I'm just computing that value. You can also see that I can change the pulse width. I can go ahead and decrease the pulse width to a percentage, which is always a percentage of whatever this value is in the interval window here. This position is this. Essentially there's 4 clocks or 4 timers that are running. The first timer is essentially just a clock that is a stepping clock. The other 3 timers are for each one of the coils, and is set based on the pulse width at the time. The mask is the raw output that's going out the parallel port. Actually shows you the data bits that are being turned on and off. I had a little problem with one of my lines on my laptop, and so unfortunately I had to skip one of the bits. Normally the mask would be counting, instead of counting 1, 2, 8 as it is right now, it should be counting 1, 2, 4, and that's just setting bits D0, D1, D2. In my case, I'm having to step from D0, D1, D3 back to D0 again. Now what will happen is if I increase the pulse width, you'll see some overlap on the coils that are energized. So you can look at the mask here, and you'll see that the mask will have 2 bits set at times. Right there, 10, 9, 3, 10, 9, 3. In each case you're seeing 2 bits set due to the fact that there is overlap in the coils firing. The next thing we'll do is we'll just take a look at the actual Visual Basic code, which is pretty straightforward, and it should give you a good understanding of how this application works.